How's it going, everyone? Welcome. Elder Gonzalez here again. Today, now we're gonna continue to keep looking at the generators, right? And how now this generator actually is the way of how can we now have a syntactic form to describe the state machine in JavaScript. Previously, we can do that, but it requires a lot of work to get that. So now this way of introduce now a behavior that allow us is to not run a function to completion, which is one of the things that function at the end of the day is known in JavaScript. So once you get into this function, you're going to evaluate that until the end, until it finds a return, or if there is no return, by default, you have now, it returns an undefined. So this doesn't mean that you can or mean that this doesn't that doesn't mean that stopping us from calling more function inside of the functions, all right? But with this functionality, with this generator, right, we have now this ability to now prevent or to stop the execution of a function. So we don't need to run to completion to that. So in concurrency programming, when you have now this preemptive concurrency at the middle of the functions, not a function but some computation, someone can interrupt this to compute something, okay? This is now called as preemptive concurrency, and because of that, things like resource sharing, semaphores, and all that kind of wilderness that concurrency programming concept needs to as a way to handle all of this concurrency in the application, especially when running is several instructions. Now, this is not a way to introduce chaos into the language. In fact, this is a way, as I mentioned before, to get now this desired behavior needed that require a lot of work to do, right? So these generators that is not run to completion, so they are not run to completion, is just to simulate this particular behavior. This is state machines. This is something that comes from Python. In this syntactic form, with after all, the syntax refers to the arrangement of words in a grammatically correct is rearranging these words for constructing grammatically correct sentence. Or in other words, this set of rules that are applied to any language that is made of the syntax, this rearrangement of the order of words, the morphology, how this word will look like, what is the shape of these words, whether they have a prefix or a suffix, the phonetics or the phonology, is that, hey, how this word sound like, at least in human language, and now the semantics. How by you rearranging all of these words, what is the meaning of this, right? So in this case, generators is the syntactic form to describe is now a state machines. And for those who are not familiar with state machines, well, this is just a way of have a pattern. It's a way to have a pattern of series of flows from one state to another to another to another, and list out all of the transaction out, and then list and descriptively and declarative, exactly, and declarative list all the transactions out. So with this, because we can mimic this behavior, this generator, this series of flows from one state to another, to another, to another, and declarative lists all the transactions out. We can use these iterators in callback to do that. But again, it requires some work to do that. And that's, if you don't know what iterator is, this is just a design pattern for stepping through typically a dataset. Now, in our case, since generators is this ability that we have now to pause and resume a function, pretty much like when you go onto YouTube and then you click on a video, you play that, right? And then you pause that, it freezes, and they will wait until you come back to resume. So this is pretty much what these generators will allow. It's going to allow us to run a function until I find a yield keyword, even in the middle of a statement, pause, freeze everything, which means it's blocking everything in this function, but not the main thread, all right? And it will wait indefinitely until some actors come and resume that. So instead of with iterators, because at the end of the day, this generator or return is an iterator, right? This generator function is returning is an iterator. This design pattern for stepping through typically data sets, but in our case, we're gonna stepping through the generator flow control, flow execution. That's something interesting. So this flow execution here is something that we can use this to generate, as the name suggests, values out of that. We also look at a couple examples of how can we yield values out of this. And anytime you create a generator, now it's returns you an iterator, which is now this mechanism, this pattern that tells you, hey, now I can. So this is the way of how you can actually iterate through this generator's flow control. So we also look at how can we do that. For example, to mimic some typing patterns. That was quite interesting, by the way. If you, for example, here, all right? So anytime when you start here, what we're doing is just calling this function when we are defining it inside of this is our generators. That'll be called anytime that'll be called is giving a particular data that we pass through that, in this, giving a particular string, which is hello world, okay? And it's going to iterate through each one of those characters, so yield them in a while loop until it is done, until it traverses through that series of flow. For example, here, as you can see here, right? So implementing typing animation with generators. Here we define is our function, right? Start animation, the call here, that we're going to define is the generators that is going to receive is a text here, and we're going to now yield each one of those words until there is no more words in that. So we can use a for, or we can use a while as well. In our case, we use is a for of loop, which is a way of how we can consume now iterators here, okay? And by the time we call this type of animation, we get these iterators, okay? Initially, we set up the output context to actually, anytime we start here, we start from the scratch, right? So we reset the animation here. And then after an X amount of time, with the timer, with the callback, this is what we like you now to trigger is the next iterator, which is what we're doing here, right? Hey, I would like you to now is trigger that. And the result, which is now this object that this iterator gave us to us, which is the pattern, the shape of this object, which is now an iterable and an iterator. In other words, is returning us a shape. This iterator returning us a shape with the next and the down and other methods. What is relevant for our case is the next here, where inside of this, so when we call this function, we're gonna get is an object, and it can take the value as well as the done to verify, hey, if we are done to go through this, to stepping through this data sets. In here, we are using is now this generator to stepping through a data set. That's what we're doing here, right? Just like that, we're using this generator to stepping through a data set. Perhaps a more complicated way to do this, or a way to get into a function stop, right? Which is what we're doing here. Is like, hey, get into this function, stop the execution, and then after 1 second, so get into this function, yield that, freeze, pass control, and then wait for 100 milliseconds, call that function, so to resume, find a yield keyword, pause, freeze that function, pass control, and then after 100 seconds is again the same. Resume, find the yield keyword, pause, pass control, and so on and so forth. But this is now how this particular state machine is now producing sequence of data, how it generates this data sets, okay? But there is a more interesting case here. Let me actually show this animation here. See? Hello world. But as you can see here, we can implement this kind of behavior with callbacks, timers, and generators. But this is, again, something that is the more relevant or the more interesting use case of this is that now when we work with async data, we can get the value out of this. So we now solve is the non-sequential, the non-sequential and non-local reasonability problem. So, because this course, after all, is about the asynchronicity, okay, and how do we do things here, and shout out to Kyle Simpson, completely, man. Where here is describing is, hey, let's go to now figuring out is what are the patterns that we can use, or we have been using over the couple past decades, all right? And also, what this pattern allow us? What is the challenge that this patterns provide for us, and some of the problems, all right? So we can now identify each one of those problems, and this is not only the callback held in the case of callbacks, but also is the problem of inversion control by passing now a callback or a set of instructions without having the guarantee that whenever we pass this set of instruction, how many times that function will run. Hey, I would like you to make that function to run not too few times, not too many times, not too early, not too late, not losing context, so don't swallow errors, right? And this is one of the big issues with the callback here. And also is that they are not reasoned about. Why? Because at the end of the day, they are not resemble the way how we plan things. Okay, so they don't look like the way how do we make create strategies here. How do we plan things? So that's why we look at, for example, thunks. That even though that thunks actually solve the problem of eliminate time as a concerning factor, especially when you need to handle and coordinate all of this response, okay? Because that's the main value proposition of thunks, is that, hey, eliminate time as a concerning factor by giving everything that this function needs, and let me wrap that value. So by the time that that value is there, it's going to receive now a callback, this thunk, so you can get that value out of that, right? So thunks are great for that, for eliminate time as a concerning factor, okay? So we don't have, I don't know when this data will arrive, but by the time it does, please, now I want to run this, I want to get the data out of this using a callback. So the other alternative was the promise. Now with promise is coming from a programming language called E, which is created by one of the TC39 commit members, Mark Miller. So shout out to Mark Miller as well, as like Jesus. Where in that language they have something called like future values, right? So this promise, okay, one way we can think of this because is as a callback manager, okay, or as an event listener, that by the time that we can is get our data, okay, so by the time that our data is available, we can subscribe to the .then and pass a callback to actually starting to work with that. And also that promise is this IOU, right? Is this eventual completion of this future data. But these two way of thinking about promise is give you a more perspective when it comes to work with that, especially when you need to use that for making several AJAX requests or several asynchronous requests, okay? Whether it's on the local database, so for example, the local storage, or the DOM, when you need to query some elements and wait for that, okay? The DOM elements, the animations. So for animations, query DOM elements, or the local storage, or doing AJAX requests, all of these things that you need to wait, promise is a good way to represent is this need of a placeholder that eliminate time as a concerning factor, wrapping around a value, right? So the thing that promise give us is that this trust that even though that we pass a callback, but here this will guarantee us that now this function is gonna run once, as long as they get the data, we can have access to that, and we can subscribe to this particularly event listener like the .then. How can we now compose is several of flow control in data flow, and this composition is something that comes a lot of the time from functional programming, right? So with functional programming, especially a promise, is a monad, and I'm just going to describe that in terms of functionality, right? A monad is a way to model is state change. So, for example, Redux is a monad, so promise is a monad, right? It's a way how you can model is this state change. So by the time you get the value, hey, all right, we can do something about it. This is the way how we can model this. This goes beyond the scope of today's video, but just to mention that, right? So promise now solve the inversion control, okay? Because this inversion control, as I mentioned, is that you're passing a callback, you're passing a set of instructions that at some point it will run. So you don't have, so you're delegating this control. You don't know when that function will run, but now with promise, we know when this function will run. Okay, so we have now this guarantee here. And this guarantee that we know how this promise will run is because it's now introduced to the language for that. It is using this monad concept. In any case, so with generators, right? Now the problem they solve, because at the end of the day, with promise, we can define is we can subscribe to an event listener like the .then, and then by the time that value is there, start to do something, right? So we can get the value out of this, and then now define is the flow control and data flow. We also have some other abstractions, for example, like promise that all settle. Promise that all is one of them. Promise that all settle. All right. So promise that all is say, hey, fulfill when all promise are fulfilled, and reject if any of them is rejected. Okay. Whereas you have, for example, all settle would say, hey, now fulfill all settled promise, whether it is reject or fulfill. All right. So I just want to now have a more fine-tuned control of which promise fail which promise fail and which one succeed. Okay. So now I can do some rollback logic here. Something useful, especially if you are now, for example, is querying to a payment gateway with like Stripe, and then you now is store that transaction in your own database, and then talk after that to your analytics service, right? And if any of them fail, you want to find a way to undo that operation, right? So that's very interesting. So again, promise solve the this inversion control problem, but doesn't solve is the non-local, non-sequential problem, which is one of the things that generators, when we started to see how can we is combine that with our async or with a timer, okay, which is a very, very interesting thing here. How not only generator is a way to describe its state machine, but also is served as a message passing. You can pass message to that, and you can also get message out of this. So because initially, if the first time you run your generator with Next, if you pass any value, right now is just fade away. It's like it's not there. So this is now a part of the flow design. And the other is that by the time you call now subsequent next function, all right, you now is can pass data, and the yield keyword once it finds, for example, let me see if I'd actually add this. I'm supposed to add this. So for example here, yeah, but this is just to put it this. Yet let me actually make the things more reasonable. In this case, yeah, but here, well, by the time we run this, okay. So we can create a new band here. All right, and define a new band here. Where the point of this is, I'm going to define now a wrapper function to anytime I call this. I'm just going to call this the run method from this function, which is call here coroutine. Okay, and this coroutine is going to take the generator, and anytime we call this, I'm creating a closure for that. Okay, to actually get this IT and this iterator from G anytime I actually call this generator, and I want to return now a function here with the arguments. That's one of the reasons why I'm using function here, because we can have access to the argument object, and the value of this is contextual. So because of that, all right, because the value of this is contextual, I just want to return now the it dot next. So what I want to do is to now return now the next function with the proper context. So in this case, I want to return is the next and apply, okay, the context for this function, which is the first argument, for the value of this, with the iterator, right? This object, this data that it needs to, as well. This is when things started to get interesting here. Or the next in iterator, okay. Next in iterator, but I just want to take a look at the having a next method that returns an object with two properties here. So this function here that is going to return is these two property, okay. So I want is to exactly this function that is going to return this property, okay. So what is my issue here? How do we know that this is the data that this needs to? You know, how do we know? Very interesting. Okay. How do we know that when we use the dot apply method from a function in an object, okay? How do we know that when we use the apply method for a function in an object, how do we know? Okay, how do we know what is the value of this? Yeah, how do we know what is the value of this? How do we know what is the value of this when we use the apply methods from a function? Or how do we know what's the value of this to be passed on when, or to be passed on when we use the dot apply method from a function? when we use the .apply method from a function, I want to be and then provide. So for example, when we call a generator function that provide a iterator, and then we want to know what is the relevant context to pass, what is the relevant value of this to pass to the iterator, dot next method when we call it. When we call it to create a when we call it to create a method, when we call it to create a utility function called coroutine coroutine to return a function. Return a function that call the next method. I think it's overcomplicated that. Okay. But let me actually is now provide this general aspect and then fine tune that. Oh, okay. How do we know that what's the value of this type apply method from a function in JavaScript? Yeah, because I think this is quite important. Exactly. If you pass undefined, this will be global object. If not, strict mode, or remain undefined in strict mode. You're asking about handling this binding specific in the context of generators function. Let me explain with practical example. For example, like this. Here's what we need to consider: what this or what contextual data to use. The iterator.net method should maintain it is binding to the iterator. Exactly. But how do we know that this is their binding here? Simpler or prefer? Simpler and prefer. But this is just a way to pass this data from this. The process, all right, and processing. So, but in any case, this apply here is a way of how you can now pass this particular context, how you can inject the context, inject dependency to this. All right, so this is now the value, this is the data that it needs to follow by the arguments that is going to receive that. And this argument is, well, by the time we call this function here, right? So it means that if we now call this and say, hey, run, okay? Or we can say step, right? Step, and we say coroutine, okay? We call that. Now we're gonna get a step here. Okay, we can call this a step, but at the end of the day, we're gonna get is the methods for that, right? And for example, if you want to pass some sort of arguments to this, you're going to pass down those arguments to that. So in other words, it means that here we're saying, hey, I want to now go to this coroutine, okay, and it's going to accept now the generator, all right, which is in this case, hey, it's function generator like this, all right, this coroutine, and this is what I'm going to do, right? In this function coroutine, I want to do something like this. I want to yield, okay, yield 1, and then yield 1, and then yield 2, and then yield 3, right? So by the time I call step, I want to actually know all of that, right? So we're calling is this only once, okay, and then only 2, step 2, step, okay, and as you can see in the console, and as you can see in the console, all right. Now that you get it, as you can see in the console here, come on, man. Well, this is what we're doing here, right? You can say clear the console here, all right? And as you can see, we're actually calling this as expected. So far so good, because here we are defining is now this generator, right? But a more interesting case of this is that it's not only capable of passing arguments as a message passing, but also a more interesting case is that when these generators pass control to some function, and then now you can run. So and when he passed that function, now you want this to this is more useful for asynchronous programming, okay? And let me explain that and elaborate this with a particular function here. We have now this function step, this function called get data, all right? You're gonna receive that data, okay? You say data, all right? And this data, we're simulating that we're doing some async operations. So we got is this. So after 1 second, right? I want you to now trigger is this callback here, right? And in this case, I'm using is the arrow function because I want the value of this keyword, if I'm going to use that, is being lexical, and I don't need the arguments property here, okay? And there's some other nuance here with the arrow function, okay? So the plot here. So view all, remove this, understanding the valid password apply function, fundamental client servers, yeah, I don't think generators are iterables, data-driven app for analytics, troubleshooting free files data. Okay. So summarize the difference between arrow function and normal function in JavaScript. Oh my god. Exactly. The this binding. The value of this refers to the person. Okay. Where now here is lexicographic. Is here. So here refers to where it was written, okay, and this refers when it was called here. So the argument objects and the construction capability, so you cannot return that, and the implicit returns. So, but here this function here, the value of this will be lexicographic. In this case, we don't care too much about that. But what we care is to say, hey, I want you to now, instead of doing this, all right, I want you to now call this step here and pass the data, right? So by the time we call this, okay, I want to say, hey, call the get data with some values, then store that value here in your generator with X, and then after that I want you to yield this data, which means pass control to this function 30, right? And I want to store that in G, and then do some expression that declares on the statement here. Say, hey, 1 plus 2, all right, and then 1 plus 2, right? And then after that, we can say is console log, say the meaning of value is, or you can say using template string, the meaning of life is X plus G. So I want you to evaluate this expression here, and what we can do is to then run this. Right? So by the time we run this, it say, hey, yields are reserved identifier. I know. Yeah, we're in a functor. So what's the issue? Yield is a reserved word. Yeah, but we are in the middle of evaluating here this data. Will you evaluate that? Yield is a reserved identifier. Yeah, that's right. That's for sure. So let me use this, right? Yield is a reserved identifier, but yeah, good. Why do you think that I'm using it in other way? Syntax error, yields a reserved identifier. Alright. What's the yeah, I'm yield this. I am yielding this as it is.
I'm going to yield. Wait 20 years. They always are, aren't we? Here's our right sync.
Unless we need to wrap them into an expression here and say, hey, I want you to evaluate this expression here similar to this. Hey, JavaScript, whatever is on the parentheses, hey, I want you to evaluate this expression. Okay, okay. It's because it currently identifies the token there. Okay, it's like, hey, I don't know what is this. This is a reserved keyword. It shouldn't be here, but I'm telling you that this is the expression that I want you to evaluate this. And as you can see, we get that meaning of life, right? So let me actually clear this up here, right? And somehow find a way to rerun this. Okay. So by the time that this is now run, so the meaning of life is that, right? So this is huge because now here, as you can see, we can have the ability to write synchronous code. We have the ability to write asynchronous code to look like synchronous. And how can we do this in the context of generators? Is by now, anytime we call this generator function that is exposed, that is returned as an iterator, by the time we get into the generator function and it evaluate the yield keyword, it's going to now say, oh, I'm going to freeze this generator, this function in pass control. And it pass control to the timer, in our case, this particular async operations. And by the time that that is done, now that is when it's gonna call that and resume the generators, right? So we can now, once we get the value out of this and passing that data, this value here, now we can continue to evaluate. We resume the function execution until a new yield keyword is found. This is huge, because this is exactly what it's doing with this generator. Is that I'm going to define the generator. That's right. Once I call it, which is now I get this object, this representation that allow me to stepping through typically data set, but in our case is through the generator flow execution, okay? And anytime I call next, I get into the generator function until a yield is found, pause, freeze everything, block this function, not the main thread, and pass control. And wait indefinitely until some actors now control the iterator and call that next function so we can resume that. So you can see that it is a bad idea to define or it's a bad idea to let some other people or some other part of your code handle these iterators, because you can be in an unstable state or in a state that you don't want to. But for this particular concept, when you implement that with the promise here, or with the plumbing here, you can imagine here that this is exactly what it's doing with this asynchronous function. Holy moly, bro. All right. And not only that, there is also the hard part. So for example here, we can say, hey, instead of actually doing this, all right, they said timeout, there was the hard part of asynchronous programming here. Okay, when we take a look now at the async and await generators here, okay, and how in our case, yes, because we are yield something, we're yield some data here, we can define is our function in terms of actually yield something. So for example, we can define is a generator function here, that this is when we're going to perform now our asynchronous operations. All right, let's say let's going to do is this HTTP. There is a placeholder API, placeholder API, right? So we can consume that. JSON placeholder is this one. Oh, there you got it. That's right. So what we can do here is look at this. Hey, by the time we call this generator, we're going to now define some data here and say, hey, I want to yield is this network operations here, okay, which means that by the time I yield this, I'm gonna pass control to this fetch function, okay, and inside of this fetch function or this asynchronous operation, okay, I would like is to now because it will wait for that to complete, yield the yield keyword, because it's going to evaluate this, right? And as long as it follow that, you can get some value here, right? This is interesting because what it's doing is that, hey, I want to pass this control, and by the time that this is done, okay, we would like to get now the data here. I want to console log the data, and that'll be all for this. So you can, here is to say flow or create flow, because at the end of the day, that's what this generator are. You're creating a flow here, okay? You are now, we want is to create now a function to simplify our life by calling is.next, okay? But in this case, let's gonna do this by saying create flow, and here say call the create flow that is going to return us an iterator, okay. Well, let's going to call this the next value, but I prefer to call it as it is, an iterator, okay? And by the time we get this iterator, I want to stop calling this function here. I want to call this. So by the time we now, in this iterator, we can have access to a value called next to get into this, all right? So the first time we're gonna get into the GIL, yes, we're gonna get into the function generator and say, hey, let me find GIL, okay? Fetch this, and it won't return anything, okay? But on the next time that we call it, it say, hey, this is undefined. Or we can say is, hey, I want you to know GIL is data here, right? But the thing here is that in this case, we need to somehow is receive that data, right? We need to somehow is receive that data. Because you make this particular courses and all that kind of stuff, but the thing here, okay, is that by the time we run this, and this is do when data receive, okay, it's because we need to somehow, we need to somehow here is, okay, so this function here, okay, so we need somehow to do something here, because look at this, by the time, okay, so by the time we get into this iterator the first time, okay, by the time we get this iterator the first time, we're gonna get is, look at this, we define is our flow, okay, so what are the series of steps that we want to go through? Hey, I want you to now run this, I want you to fire up this AJAX request, okay, so yield that, which is going to return us a promise here. So by the time that we get that, we here say, hey, here we're getting is a promise here, which is our return, we can call this return value, for example, right? Or future data, right? And because here in this future data, right, we can now actually say future data, subscribe to that, and then now do something with it, right? This do something with it, all right, is to now here is when you're going to trigger is your iterator next with this value, which is future.data. You say, hey, because I want to now pass this iterator dot next, but now with the data that I'm receiving here, okay, so by the time now I call this the future data Dot then is not a function. Even though that I calling here, I'm yield this. It's because it's not value. Exactly. It's because it is not value. And here we got is this. So it's a hey, exactly. We're getting is into that. So use your own data. And here I would like to get is now post one, right? We use this now, say post one. Doesn't have any post one. But because it must be in plural. Post one. Really? Interesting. I don't have anything of there. Oh, because I need to transform that into a okay, exactly. Because I need to transform that into a to JSON response. Or you get that data, exactly. You get the response, and then you say response here of data. That'll be response, and transform that buffer into a JSON, bro. So now we'll be able to access to this. Wait, what? Exactly. So by the time we get this value here, feature.then, which is it's because it's passing control here. So look at this. Here you are passing control to this. All right. And by the time that this, you're passing control to whoever is controlling the iterator. All right. And in this case, it say, hey, call this iterator dot next dot value, which is now a promise here. So by the time you get that data, all right, I want to say the next time of the iterator, I want to pass down that data here. And of course, this data is as a JSON here. You can say it's like this one. Right, is a response here. You say the JSON. Okay. Because now, interesting here. Because now this promise or this response, okay, it returns now the method, say JSON. All right. So the JSON static method of the response interface returns a response that contains the provide JSON data as body and the content type headers, which is a set of two applications /JSON. The response status message, and additional headers can also be set. The method takes make it easy to create response object from JSON encoding data. Service, for example, service worker, for example, intercept fetch requests made by the browser and might use JSON to construct a response from catch JSON data to return to the main thread. The JSON method can be also used in the server code to return JSON data for single-page application and any other applications where a JSON response is expected, bro. But the JSON object here Response with JSON and data object. Yeah, but this is if you want to create this as a static method. But as an instance method, okay, the JSON method response interface takes a response streams and read it to completion. It returns a promise here. A response stream, bro. But as you can see here, the JSON method of the response interface takes a response stream and read it into completion. It returns a promise which resolves with the resulting of parsing the body text as a JSON. Note that despite the method being named JSON, the result is not a JSON, but instead the result of taking JSON as an input and parsing it to produce a JavaScript object. A promise that results to JavaScript objects, this could be anything that can be represented as a JSON. And when you're using promise here, you say, hey, this particular content that I'm going to parse, okay, that this particular data that I'm going to parse into a JavaScript object, I'm not going to block the main thread for that. Instead, I'm going to pass this to the micro task queue to process that. And by the time we evaluate this, by the time that the call stack is empty, then I'm going to evaluate this. This is interesting. This is very, very interesting. Because here what it means is that because I'm going to transform these streams of data, all right? The JSON method of the response interface takes a response stream and read it into completion. What is, okay. What does it mean from the MDN docs? Response JSON, okay, response stream, what does it mean from the MDN docs response JSON methods? Exactly, what does it so from the following code, or from the following text from MDN response JSON, okay, what does it mean response stream? A string is like a flow of data that arrive, exactly. It's a flow of data that arrive piece by piece rather than all at once. When you make a network request, like fetching data from an API, the server sends back sends data in chunk. This is a response stream because it sends data in chunks. And as you can imagine, pretty much like the OC model, it's going to send streams of it. It's going to send data as chunk. This is the response stream. Think of it like watching a video that buffers. You receive the data gradually over time. That's what happened when we now try to read the entire stream. Interesting. Because this data comes as it is once we fire up that AJAX request. Okay, or using the fetch method. We need to wait for that data to come. Okay, and this data comes as a streams, as a chunks of data that is sending from the browser. So, because of that, we need to wait for construct the entire data. So we need to buffer that data. The response stream contains the raw data of the HTTP response body before you work with the data as a JSON, right? So read the entire string. So here, this response, which is a response object, okay, and we barely use the response here. Exactly. This is what it is. The read body, a readable string of the body context. So if we say, for example, this response.body, and I think this is a method that is read only, okay, read only. It say, hey, this is now a readable string. And because this is a readable string, this is an interface of a stream API and represents a readable string byte of data. So you say log, you say from, cancel, get reader, create a reader that logs the string, pipe through, pipe to T, and async iteration. Okay, fetch string. But at the end of the day, this body is in streams of data. It's because now the server is sending all of this data piece by piece as a flow of that. And the string API, what it's doing behind the scenes, okay, is now providing the back pressure, so we can programmatically access string of data receive over the network. We can programmatically access streams of data received by this. Readable streams, writable streams, transform stream, request and body, extension to other APIs, extension to other APIs, by stream related interface, grayscale a PNG, simple random string, simple T example, simple writer, an unpacked chunk of PNG. Okay. This is a very, 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 very interesting topic here. So because now, anytime we fire up an AJAX request, in this context, we're gonna get a response that on the body, it has now this readable string. Okay, this is string API that allow us to, okay, programmatically access streams of data received over the network and process them as desired, bro. Streams of data over the network here. Readable stream. So if we want to access to this readable stream of data, okay, which it say, hey, this readable stream get reader, okay, creating a BioB reader. Zero copy transfer of the response here. A simple stream pump. Using custom string. Using custom string. The body only property of the response interface is a readable string of the body content. Is there any way that we can read this data as it comes in? The stream is a readable byte stream. Jesus. The stream is a readable byte stream which support zero copy reading using readable stream by our current browser don't actually conform to the spec requirement to set body property to null for response with no body. For example, response head request or 204 context here. Okay, but it can be in this form, and body can be a blob array buffer. I am quite familiar with this array buffer. Okay, how you can now represent this a series of how you can represent binary data into a collection. Okay, but if we can now read these streams here, create and returns a readable string object for giving handlers. Okay, so now claw, how can I read a readable stream from the response and print and console log? You get the body get reader and text decoder. This function is gonna be able to read this. If it's done, this one. And value is an unsigned this. Read the next chunks of data. So respond.text. So the first approach is more useful when you're dealing with large amount of data. You want to process the data as it's arrived. You need to show progress update. You want to start processing data before the entire processing responds. The second approach is much simpler, but you have to wait for all the data to arrive before you can start processing here. Okay. Okay. So if I say something like respond.body.text, okay, response.text, so I need to wait for all of that data to be arrived. But because this is a promise here, that's what happened. Get reader body.getReader. So body.getReader this is a readable stream default reader. Exactly. You have now your text decoder here. All right. You have now your text decoder here, and the reader. This is if you want to now read the streams of data that is coming here. Right? This is if you want to read this, the reader, response.body.getReader, and then the decoder, and then you say, hey, let me create now this function that I'm going to is read this. And I'm going to call this, and I'm going to call the .read.then, which is a promise. Interesting. Which is a promise here. And I know that I'm taking quite a amount of time here, but the whole point of this is to see how you can integrate this. Hey, read stream, I want you to have access to the read, and anytime that we can have access to this promise, okay, I want to do is this. I want to get, hey, is this is done? or value. This is interesting because this reader.read is implementing like the promise, like the iterator protocol. Readable is the body get reader. Okay, body get reader, body get reader, because this implement is the stream of the readable interface. This readable interface has a from cancel get reader. This get reader method of the readable string interface create a readable and lock the string to it. While the string is locked, no other reader can be acquired until this one is released. So it means that this readable string default reader depending on the mode. And some of this example. So in the following simple example, a previous created custom readable string is read using a readable string default reader created by the get reader. Created by this. So it created now a readable string default reader. Okay. Custom string input. Reading custom string like this. Exactly, as they come in, and then the final result is this composition of this. But as they came here, all of this data, all right, each chunk is read sequentially and output to the UI until the string has finished being read, at which point we return out of the recursively and bring the entire string to another part of the UI. But this dot then from the read method, it's a get reader that is going to produce a readable string default here, where you can now have access to the read, and is implementing is the promise here, which means that this particular pattern of readable strings of waiting for data to come That's fantastic. That is fantastic. Okay. So because now so the response object is say, hey, I got this particularly abstractions that represents the eventual that represent is the response, but as I get this data here, okay, or as I now receive this series of a string of data, these chunks of data, okay, yeah. So as I receive these strings of data here, okay, which is read, return a promise that fulfill when a value has been received. Hey, I received this value, and there's another value, and there's another value, and there's another value, and there's another value. So by the time it receives this data here, okay, with the read.read, by the time I receive this data, hey, I receive this value, this value, this value, this value, this value, and I want to show them as it is. And now, call the read string here. You know, hey, this is a chunk. I receive this chunk like this. This is very, very interesting. So if you, for example, wants to get hundreds of them, for example, 100 posts in this case, right? You say, hey, I want to receive this 100 posts. Say post, right? I'm going to receive now this data. You see? Chunk, and I printed this twice. No, but I want this to just clear this, alright, and say, hey, I want to receive the post, right? Save this. Exactly, one single chunk. So if I want to receive now multiple posts here, exactly. And this is a very revealing thing here. This is a very revealing thing here. Because in one chunk, we receive all of this data. 1, 2, 3, 4. And this is quite interesting. In this one chunk, we receive this data. Right? And then you got stream data complete for this. But this is the representation of how we can get all of this data at once. $500 comments. And in comment it get all of it, but look at this how it process all of this, similar to a post. But here in our post we receive more than that. We see, hey, we receive one chunk here with this, okay, and another chunk was with this, right? And then it didn't print that out as expected, right? So decoder decode this chunk as a string. But this is quite interesting because the data is being received in strings, as in strings, chunks of data. There is a reason why here, when we explore this, we say, hey, because at the end of the day, with our generator, what we want to do is to do this. Our generator is going to create a flow. This is the syntactic form of describing a state machine. Hey, I want you to be in this state, then in another, then in another, then in another, right? And this state machine is just a way to describe those flows those series of flows from one state to another, to another, to another, to another, to another, and descriptively list all the transactions out. So first things first is, hey, let's go to define now here this, okay, that by the time that we now run this generator and we find the yield keyword, we're going to now stop the execution, pass control, okay, to the to whoever is using that generator, okay, and by the time that that generator now give us, or by the time the generator has been called, we can pass that data and get that as we want. So which mean is that hey, because we're receiving is now this response, which is a response, okay, we receive this response, and we would like to also is say comes to data, all right, and then say yield to a function that transform that, okay, which is a, let's gonna call here a to JSON, all right, to JSON with this response object, and this to JSON okay, and this to JSON, which is our response here, or another way to simplify this, to prevent this, yeah, another thing to simplify our life here, it will be is, hey, by the time I get this, okay, so I want to get the response here, but in this case I want to get the data itself, right? I don't want to do something funny outside of that. And in fact, I want you console log data here. So here I'm going to do is this. This response here with the iterator.next, because this is now a response and I need to transform this series of strings into a JSON dot JSON, okay. Now I want to be able to log this thing here. So this is a promise here, right? So it means that because, all right, okay. No, good. Because this is a response. So what I need to do is this. So hey, because we are now returning is this response, okay. And locally for us, we need to return is a promise here by saying is new promise, new promise, or you can use it something like this. You say, hey, promise, promise. This is a static method. Say promise dot then, right? Promise resolve. Okay, I want you to now pass the response over that. Okay, or you can say something like this. More likely, say, hey, response dot then. All right. So because this will now return is a response to this. Here we say, hey, this one, and by the time we get now this data here as a response, and I want to now is do this and pass this as body or as JSON, right? So hey, this response, right? So look at the thing, is started to complicate quite a bit, and I love it here. Because what happens is by the time we throw that, there's some inner pipelines here to actually make that happen. So we're gonna return this iterator with the future data that is a promise, okay? And then in this promise, we're going to actually change this. You say, hey, this is the response here. And because we need to return is a new promise here, so this is our response, and this response will generate is now a promise here. We can say, hey, response dot JSON, because this will return is a promise for that. And by the time we get that, okay, which is our data, then we can say, all right, it is time for us to call the iterator dot next, okay, and pass the data with this. And this is something pretty fucked up, bro. Slash one, and that kind of thing. And this is how you can actually wiring up things to actually simulate that asynchronous behavior. This is the next level of competency for JavaScript developers. And that'll be all for this video. Take care. Bye-bye.